Alright, welcome back. Thanks for watching. I'm going to try to stand here so close to the phone so you guys can hear me okay. But this is going to be my review for my Next Wave Automation CNC Shark HD4 with the extended bed. I did another review, but it wasn't as thorough as I think I should have been. This time I'm going to go through and I'm going to measure the movement on the axis and actually how much working space you have and some of the issues I've had with things like the Spindle Controller and the Pendant, some of the actual hardware issues I've had on the Gantry and the Z-axis. But before we get into that, I just want to take a second to shout out a friend of mine on another channel. His name's Dylan's Woodworks. Really a class act, good guy. He does live streams. He's got a I think it's a 30-inch Woodland Mill sawmill. So if you're into, milling logs and that kind of stuff, check out Dylan's Wood. I'm having technical difficulties. Check out Dylan's Woodworks. Really good guy. He's doing a giveaway at the moment, and we're going to, hopefully, we're going to try to do something where we can give something away in cooperation, almost like a collaboration type of giveaway. Not sure how it's going to work yet, or if it's even going to come through, but we've talked about it, and we're going to wait and see how his current giveaway goes, and then we'll see what happens. But I'll link to his channel in the description. You got to go check it out. Really a good guy. He's a class act. All right, without any further delays, we're going to get on with this review. So hit that subscribe button, please. Thumb it up, and thanks for watching. Okay, so first we have a table length of 63 1/4 inches by 28 exactly. So now what we're going to do is I'm going to show you exactly how much working space you have. Okay, that's as far as we can go. We have 7.5 inches from this side. Okay, which is right there. I'm going to get right up. Make sure you guys can see this. Okay. Your working space is in 7.5 inches from this end of the table. So I've marked it right there. So we're going to go from the end mill bit. And it looks to be right about 53.5. But that is to bottoming the drive screws out against the end of the table. So I would say comfortably 50 inches of working space. Okay, so now for the x-axis. I didn't say before, but the length of the table is your y. Across is your x. And that is as far to the right side of the table as the machine can go. And it is about 1.5 inches approximately from the side of the table. Alright, so we're going to put it right about there. And we're going to go as far as we can over. Oops, we hit. Alright, and we are sitting right at 25 inches, but that's bottomed out on both sides. So comfortably 24 inches on the X. 50 on the Y. Now let's do the Z. Okay, so I went ahead and removed the 1/4 inch end mill from the spindle. And this is a liquid cool spindle. Alright. 11, roughly. 10 3/4. And I'm as high as I can go. Okay, that's as low as I can go without bottoming it out. It's 1.5 inches. Obviously, there's no end mill bit or any type of a router bit in there. So we got 1.5 inches. Looks like you have approximately about 10 inches of travel without a bit. Obviously, you're going to put an end mill bit in there. You're going to knock at least 2 inches off of that. Plus, you have your material thickness. Been my experience, 4 or 5 inches is about as thick as you're going to go. But if you have this machine with the 2 horsepower liquid cooled spindle, you're not going to have the capabilities of milling anything thicker than that anyway, unless you're carving into it. To do a profile cut on a 4x4 or anything that thick, that spindle will not do it, because that spindle will not hold a collet to hold a 1/2 inch or bigger bit. So if your goal is to be able to profile cut 1 inch thick material or 2 inch thick material, then you're going to need a bigger collet. You're going to need a bigger spindle with a larger collet. This will not work for you. About the limit for this, from what I've seen, to safely be able to do profile cuts is 5/8 to 3/4 inch, and 3/4 inch even gets a little hairy. And that, when I do stuff that thick, I usually put my feed rate to about 70 inches per minute, and I go at a plunge depth of 0.05. Basically a quarter, I think, roughly of what they recommend, because I think they say go half. And so you use 1/4 inch end mill, half would be, 1/8 of an inch. So I go roughly a 1/16, just to be safe. And it'll cut through, but like I said, it gets a little hairy towards the end. It starts making some funny noises. You start getting clatter and vibrating. I usually try not to go any thicker than 5/8 of an inch when doing profile cuts. Pocket passes are different. You can go deeper on a pocket pass. And another way to get around that, to profile cut thicker material, is to do a tool path of a pocket instead of a profile. I've done that, and it takes a lot longer, but it works. Okay, I think that about covers up the dimensions. So X, you get about 48 to 50 inches of actual machinable space. Or I'm sorry, on the Y. And on the X, you get about 24. And just call it 6 on the Z. Okay. Now let's move on to the pendant. All your controls are on here. You can toggle the machine manually, up, down. Try to get this where you can see it. Away, near, right, left. You set your home position right here. Right there, 0. Boom. Okay, now I just set that as my home position. Now I can move anywhere, and then I can just press this, move 0, 0, 0, and that takes, oh. Okay, now what happened is I set my home position when it was all the way maxed out, and it has a variance, I think. It'll like automatically lift you up just so your end mill bit doesn't hit your material. So it'll lift you up, 1/2 inch or so, and then it'll travel, and then it'll set you back down. So when I set that all the way up at its max height, it tried to overextend to compensate for anything underneath. If that makes sense. I hope I'm explaining that clearly, but that's what happened. That was my own fault. So watch, I'll set my own position somewhere in the middle now. Zero that out, okay. Now let's come way over here. And to the right. And down. And now let's press this home button. And if anything goes wrong, you can always stop it too. Like when it was bottoming out at the top, I could have stopped it. This is where your USB file is, and then you can select from there we go. You can select from the files. I'm going to exit out of that. I really don't do a lot with anything else in here. So you can probably find out more information on this at the Next Wave Automation website, or probably even on YouTube. I haven't had a need to. Everything I need to do is toggle in the machine here, set in the home position. Because see, after you do a tool change, right? Say you're doing a V-carve, and let's go back to my USB. Okay, boom. That's my pocket. And you can scroll down, and it'll tell you what the tool is. Right there, I have this set for a 1/4 inch end mill. Okay, and go back up, and it tells you the pocket. I usually don't name them because I usually only keep one file on here at a time. So, okay, I did my pocket. Now it's time to move on to my V-carve. So after the machine's done, it's going to bring it back to the home position. Okay, after it completes the first tool path, after this pocket tool path is done, it's going to return the spindle back to the home position, and then it's just going to sit there and run. The spindle will not shut off on its own. You have to shut the spindle off manually. Okay, then I exit out, exit, then I'll lift the, okay, up, then I do my tool change, put in my V-bit, and then I lower it back down to the surface material with the tip of the V-bit, okay? And then I will zero it out once I'm at a proper height. And it's very sensitive. You have to get it almost exactly at the surface material. If you go too low, that will, okay. And you have to get it back to the height of the surface material, and then you zero it out. Boom, reset the home position, and it'll have a difference here on your Z-axis. The X and Y ain't going to change as long as you don't toggle the machine forward, back, right, or left. As long as you leave that all alone, only thing you're going to do is take it straight up, change your tool, bring it straight down, touching the material surface, and then you're going to zero it out, and it's going to have, you know, 1/2 inch difference or whatever the thickness of the material, or the end mill bit or V-carve bit or whatever it is you're using. Then you press OK, and now you have reset the home position. Then you can run your V-carve. Yeah, it's pretty simple. If you have no experience with it, it took me some getting used to. What would happen is maybe I wouldn't put the V-carve or the V-bit at the right home position. It was either a little tiny bit high or a little tiny bit too low, and then you run it, and what happens is the V-bit will either be a little higher than where your end mill bit was, plunge depth, or a little lower when it's all done. Not the end of the world, but just the things you'll notice as you get more comfortable with the machine. Okay, let's move on to the, okay, so the pendant plugs in right to the front. You have your emergency stop, and then in the back you have your X, Y, and Z stepper motors that plug in, and then I don't know what these other little wires are for, but they're self-explanatory. And then your power cord, and then this is your on-off power switch. Well, I just shut it down. Okay. That's all there is to it. It does tend to get quite a bit of sawdust down there, so you probably want to have maybe cabinetry or something to kind of keep it free of dust. I just I blow it out with my air compressor from a distance. I don't get real close because I don't want a chance, you know, putting high pressure air in there and busting off little wire leads or anything. So I just do it at a distance, and from the back it stays pretty clean, but you'll notice that it does get some sawdust inside. Okay. Next, you're going to need a bucket of water for your liquid cooled spindle. It's basically a power head from a fish tank is all it is. And it's quiet. You guys probably couldn't even hear it. If you've ever had a fish tank and you've ever run like a 501 power head or something like that, that's how loud it is. It's quiet. I just use a clamp to hold the inlet because it tends to pop out. I've had it happen twice where it just pops out and then all your water starts running down the damn driveway. Okay, next we're going to do the spindle controller. Okay, so this is your spindle controller. This does not plug into your CNC controller. Okay, so in other words, like I said earlier, when your tool path is complete, the machine, the CNC will return it to the home position, but the spindle will stay running. So what happens is, let me make sure I'm safe, okay? Okay, you press run, boom, and now you adjust this little twisty potentiometer deal. Right now it's at, I'll tell you when it stops, 10,800 RPMs. Take it all the way, it should be 24,000. And there are, when I got this, it was set to some other random, okay, I better plug in the water. Okay, when I got this, it was set to, oh wait, there it is. That, it was on that. I don't, it just says 400. And I wasn't sure how to read it. And finally, actually, one of you out there helped me. I didn't realize, I knew it wasn't RPMs. I just figured it was, because it's made in China, I just figured it was some kind of, I don't know, metric equivalent. I don't know. I didn't think much about it. I just kind of eyeballed it. But now that I figured out you can shift with this little shift key, and you just keep toggling it. There's all kinds of different settings. I don't know what any of them are. Like this is ROTT. Now we're back to the 400. I don't know what that is. Now we're back at the RPMs. So if you can't figure out how to get that 400 off of there, because mine came like that. That's how you do it, with the shift key. And it's that simple. That's as loud as it is, so it's pretty quiet. Here, I'll get it up to a full roar and let you hear it from the top. Okay, that's as loud as it is. It's really quiet. What makes all the noise is when you're hacking into material. That's the loud part. Now, there is something I want to show you. Let me turn this off. What we're looking at is the bottom of the liquid-cooled spindle. Now I want to show you something. You see this? With the 4 spanner holes or whatever those are? Okay. Mine comes loose. I do not have the right wrench. Almost like what you would use to change the grinding disc on a grinder. I don't have it. I need to make something. So what I have to do, this comes loose and it'll just spin all the way down. It doesn't hurt the machine. It doesn't appear to anyway. But what I have to do is I have to put my wrench on my crescent on here, or wrench or whatever. And then I use my snap ring pliers and I just pull. And that'll keep it cinched up for, it depends. Usually a couple weeks, 3 weeks, but you can see all them scratches there. That's where my snap ring pliers pull off and scratch up the bottom of it there. So that is a complaint I have. They do not send you a tool to tighten that up with. You're going to have to make something or hope that they actually tightened yours up tight enough, because I suspect that's all it was with mine, is they just didn't tighten it up enough out of the factory. And it was instant. I mean, within the first few days, that thing came loose. And that's something I still deal with. Anymore, it's not quite as bad. as it used to be, because now I go very conservative with my plunge depth and my speeds and feeds. I started breaking too many end mill bits. So just be advised, you want to look for that. Let's move on. Okay, so what we're looking at now is the Z-axis, where the drive screw is. They have this screw drive. You can see right here these screws. They're tight, but the washers are shifting. I'm afraid to tighten them down because they're still tight. I don't want to over tighten them because I know that it's just plastic, it seems like. And last thing I want to do is strip something out while they're still working. But I think eventually I'm going to have to deal with that. You can see it from this angle right here, actually. Look at. Let me try to straighten this up here. There we go. See that? Eventually I do believe that is going to be a problem. Let's move on. Okay, now the thing I want to point out is, I hope this is going to come through. I want you to listen when I start to toggle this thing. You're going to hear a howl like this. Whoops. Okay, of course it's not doing it now. Okay, listen. Hear that? It's intermittent. Doesn't always do it. It's got to have something to do with that drive screw and this thing I just pointed out to you. And it'll do it on all three axes from time to time. But the Z-axis is by far the worst. Is it a long-term issue? I don't know. It could just be, you know, creaks and squeaks that machines get over time. But I don't know. It shouldn't be that way. But the machine works fine for now. So we're going to cross our fingers that it doesn't become an issue. Okay. Now on the table, you get these clamps. You get two. What you do is, they're flat on one side. There we go. They're flat on one side, and they go in these slots. Boom. Now, this is something I want to point out. Earlier we came to the conclusion that you can mill about 24, 25 inches on the x-axis. Okay, but something to consider, if there's not a lot of extra space on your material for clamping, these clamps get in the way of this lots of the times. Watch. Okay, so you're milling along. Whoops. This will hit. I don't know if it's so you can see it, but see, I don't want to go anymore. But if this was out here and you're working on a smaller piece of material, you can hit these, and what happens is this will slip through the drive screw and it throws off all your coordinates. All your G code will be totally foobar from that point on. because this thing thinks it moved the distance that it was supposed to go, but really this drive-through stopped it. And really, all it does is it just makes that stripping sound that you hear when I bottom it out. And at that point, none of your G-code is good for the rest of the file. You have to start all over. Chances are your material is lost, everything. So watch out for that. Another thing I want to point out is the gantry. It looks really nice, right? However, it's aluminum. This is probably 1/4-inch aluminum, and this is some kind of black carbon, like plastic, ABS or something. See that? It gives, and it also gives this way. It'll twist like this. I don't want to go doing it too much, and generally it's not too much of an issue. However, that being said, I've made a few attempts to mill aluminum, and it becomes a bigger issue, I believe. If you want a machine to mill aluminum, you don't want, this machine isn't going to do it. Well, look I don't want to bash them, okay? The machine is good. I have no problems milling wood, other than, learning curve problems, and most of the stuff I've had was my own issues, my own problems, my own mistakes. But I know the gantry is not supposed to twist like that. And if you were to buy a machine with a steel gantry, it wouldn't. So I think what I'm going to do is I'm going to rebuild my gantry over time. Not sure how, not sure when, but eventually I will. So just take that into account. If you plan on doing a lot of aluminum or things like that, I don't know, you may want to do a little more research first. I haven't had the best of luck trying to mill aluminum. You can go look at my 3 or 4 projects I've done with aluminum, and they weren't all that. Matter of fact, I wouldn't call any one of them a success. Now, is that my own incompetence in naive, being naive and not knowing? It very well could have been. So I don't want to come out and lay blame on Next Wave when it could have very well been my mistakes. But I'm just telling you from my own personal experience, I have had 0 success milling aluminum. Okay, so that brings me to the $25,000 question. Would I buy it again? Taking into account the rigidity of the gantry, taking into account the customer service experience I had with Next Wave Automation, taking into account how much I use the machine, it does handle a load. I mean, I use this thing every day. Sometimes only for 45 minutes to an hour, sometimes 5-6 hours. So it's not uncommon on a weekend for this thing to be running throughout the course of the entire day. So it does get used. I mean, I've had it 10 months or so, and I've done well over 150 signs. So it gets used. No, I wouldn't buy it again. To make a long story short, I had a bad customer service experience with them. The rigidity in the gantry and some of the little issues I see, like I know the spindle isn't made by them, but hey, I bought it, it came with it, I still hold them responsible for it, and I have 0 confidence that if I called them and said, hey, this spindle, blah, 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 they wouldn't do anything about it. So I'm not even going to waste my breath. I'm just going to have to make a tool and figure out how to tighten that thing up. Maybe I'll drill some holes and use some pop rivets and weld on a little handle and make something like what you would use to take the grinding wheel off of a grinder, something like that. I don't even know what you call the tool. I've tried looking it up, and I gave up. I was like, I'm not going to spend too much effort on this because it's really not that big of a deal. I can just use my snap ring pliers to tighten her down. No, I would get a Laguna or an Axiom or something that has a steel gantry. They're almost at the same price point. The difference between those, like for example the Laguna and this, is for one, the Laguna has a little bit of a smaller table. I think it's like 2x3, and you'd have to buy the VCarve Pro or Aspire or whatever program you want separately, as to where the VCarve Pro is included with this. And when I was buying it, that was a $600 savings. Plus, they were a little cheaper anyway. I want to say the Laguna was maybe $500 or $600 more in addition to that. Plus, the additional 600, or unless you buy Aspire, then a couple $1,000 or whatever it is. So it can be quite a bit more, but when you're spending that kind of money, get the steel gantry. I hate to beat the company, but they really haven't been there for me. One of their people saw one of my videos on milling aluminum, and he jumped on and showed me told me some pointers in a comment. But that's the only interaction I've ever had with this company. So I can't really give them a good grade for customer service. I know I've had people post comments talking about Carvey and the customer service they get with that company, and everybody claims it's second to none. And I want to know one thing: when I spend this kind of money, I want to know that I'm going to be taken care of if there's a problem. Like for example, I was thinking about putting off the warranty when I bought it, right? Because money was short. I was already spending a lot. I'm like, okay, well, can I buy the warranty at a later time? Like because I think this came with a manufacturer's 1-year warranty, I think. And then I was going to buy the additional 2-year warranty. I couldn't even get a call back for anyone telling me if that was an option, if I could. I didn't even get a call back telling me that I couldn't. Nobody, they just didn't respond. I was like, you know what, whatever. So I didn't buy the extended warranty. And I don't know that I'm going to need it. It seems to run fine. So I'm not too upset with that. But I think one day I am going to rebuild it and put a steel gantry on it. Just make it my own at that point, since the warranty will run out pretty soon anyway. But yeah, I appreciate y'all watching, and I hope this helps you out. If you have any questions or comments, throw them down there. I'll try to help you out if I can, or if you think I left something out. I'm still a rookie to this, but I've gotten better. But if there's something that you wanted to see that I didn't do, throw it down in the comments, and I'll be glad to go over it if I can. So I hope you have a great day, and thanks for watching the next video. I'm out.